Okay, sorry, y'all, forgot to record today. So we plotted the points, and we labeled them. Okay, and we were talking about how quadrants are labeled in the shape of a C. So this is your first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, now it says which quadrant is each point in. So A is in our first quadrant, B is in our third quadrant, C is where, y'all?
Second quadrant.
Okay, what about D?
Is in our fourth quadrant.
Now, what about E and F?
E is in both. No sense.
So if you had to be specific, what would you say?
It's in between.
I'll say it's 4.
It's on what? What line is that?
1x.
X-axis. Okay, so what about F?
Y-axis. I say F.
Yeah, because they're not technically in a quadrant. They're on the line. Okay, so we're going to specify by saying on which axis they're on. Okay? Any questions with that?
No.
Okay, so we're going to talk domain and range. I know it's probably been a while since you've done this. Okay, phones away. Domain is all possible x values. It's also called your input. And a lot of times you'll hear me call it your width. Okay? And you're always supposed to write at least to greatest, so you start farthest left and you work your way right. Okay? Range is all possible y values. It's your output, and I call it your height. You start at the bottom and you work your way up, so that way it's least to greatest. So a quick algebra 1 and 2 refresher. Do y'all remember hearing the words discrete or continuous?
No.
So discrete was when you only graphed it with dots. And when you do domain and range, it's going to be in fancy brackets. They're actually called braces. And it's going to be a list of numbers. Okay? Continuous. I had to really sound that out, y'all. Okay, is graph with lines and dots. And it's doing domain and range like we've been doing with the brackets or the parentheses. Okay? So that's what we're used to seeing. So I want you to realize that it's asking us for the domain and range from this example. Okay, and this is dots, therefore it's going to be a list inside braces. Okay, so domain, I said, is your width, and it starts farthest left to right. Now, technically, did it tell me all my x's right here? Yes, but they have to be least to greatest, and I want you to understand that you're not always going to be given the points. So I'm going to show you how to find it from the graph. Okay. So remember, we start our farthest left. Which point is the farthest left?
C.
C. How far left is it?
Pretty far left.
Great, thank you. -8. Okay, then B. How far is B?
B is
F. A. E. And D. Do you see how when we worked left from right, it stayed least to greatest? Yeah. Now, technically, you could have gone through here and been like, okay, -8, -2, 0, 3, 5, 6. Okay, but I can't look at numbers like that. I get lost in them. And then I have to erase things or cross things out, and I get annoyed. So, I personally like to look at the graphs. So now range is my list of y's, because this is discrete. Or we start at the lowest and we're looking at the height of the dots. So what's my lowest dot? F at -6. Then what? Next.
negative 1,
Then.
0,
Then.
1,
Then.
5. I got lost for a second.
Great job. Okay, so we're talking about our heights. Okay, 2 things to know when doing domain and range. It should always be least to greatest. And don't repeat numbers. So what if there were like 2 dots at the same height? You would only write that height once, okay? There's an example of that on your practice that I'll show you here in just a second. So that way you know what I'm talking about. Hmm?
Like how you have a star in the beginning, then you put a little bit.
I don't know why I did that. That's so weird. Thank you.
It's called a teaching.
It's my brain. Starts with a star, ends with a fancy bracket. Okay. Okay, so 2 more definitions. A relation is a set of ordered pairs. I want y'all to know that ordered pairs is just a fancy word for points on a graph. Who can tell me what a function is?
Whenever they all line up to like 1, right?
What cannot repeat?
The X.
X. So it's a relation where X can not repeat.
I remember my 8th grade teacher said something about if the X repeats, he's cheating. So that's how I remember it.
Oh.
Because it's the X.
Because if you want a functional relationship, you gotta stay with one line. I don't know if she was going through things, but that's what she said.
Sounds like it.
Or X cheated.
That's funny. Okay.
I like that.
Okay, these 2 are called mapping. I guess technically this one could be called mapping too, but when you see these little ovals, it's just another way of building a table. Okay, these all mean the same thing. Okay, so it says, are these functions or relations only? Okay, everything's a relation. Okay, anytime it's graphed and got ordered pairs, it's a relation. A function is specific, though, in the fact that X cannot repeat. Relations don't care. Okay, so knowing that, here, does X look like it repeats? No, and to prove it, I'm going to write out the points. You don't have to do this, but I want to show you something here in a second. So it goes negative 2, 3, 4, 6, and 5, 5. So no, X did not repeat, therefore this is a function and a relation. Now, what about number 2? Does X repeat? No, but does Y?
Yes.
Is that okay?
Yes.
Yeah, it's totally okay that the Y repeats, but X cannot. So this is also a function and a relation.
So X can't cheat for 1.
I didn't come up with that analogy, so I don't know what her walk around that was. Okay, this is the reason I want you to see the table. So negative 4 goes to 6. Every arrow represents a point. 2 goes to 8. 7 has 2 arrows, so it's 2 points. Did X repeat? Yes. So I want you to realize anytime an X value has 2 arrows, that means you have 2 7s, therefore it repeated. So this is a relation only.
You can start teaching kids like that. If it repeats, if they cheat.
17 on a negative 2. Wait. What?
I'm not using that analogy. Thanks, though.
Said 20.
Okay, do y'all remember the test that you did to test a graph?
Yes.
What's it called?
Linear equation.
It's a line.
It's a line. What kind of line?
Over.
Straight.
Vertical line test. Good teamwork, y'all.
Teamwork makes the dream work.
It does.
But there's a M-E in team. So it's only me.
There's no M, E in team. Oh, team. Okay, I don't know why I was... Goodness gracious. I was thinking like in order. I don't know. Okay, so I want you to realize when you draw a vertical line, if it touches 2 or more times, it is not a function. If it touches 2+ times, it is not a function. So I want you to realize you can draw a line right here and it only touches once, right? But what if I draw a line, gosh, if I draw a straight line right here? Doesn't it touch like all through that middle piece? Therefore it touches 2 or more times, and this is not a function, it is a relation only. What do y'all think about this one? It is a function in relation because it doesn't matter where I draw a vertical line, it only ever touches the graph once. Okay, what about this next one? This point overlaps a solid line, which means x repeated there. Okay, therefore it's a relation only. Now I understand these are not normal graphs that you see like on an everyday basis. Okay. And this one, what about this one? Well, there's a staple, so don't judge my not straight lines. It's actually a function and relation because open dots represent a hole in your line, solid dots represent a spot, so therefore it's not overlapping. Does that make sense? Okay, open dots pretty much just represent like a hole in your line, like that's not a solution. But everything to the right and the left of that open dot is a solution. So since I have a solid dot above my closed dot, it's still a function. A solid dot above my open dot, not closed. Man, hopefully y'all followed that.
I forgot everything already.
Good thing you wrote it down. No,
I was writing that.
finish this page and then we're done. Okay. Then we also have function notation. What does dot 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 mean?
To be continued.
Yeah, like I could keep going. Okay. When writing in function notation, do you think the letters matter?
No.
No, you could use d of x, s of x, b of x, a of x. It doesn't matter. M of x, n of x. It doesn't matter. Okay? And the way you read those is f of x, g of x, so on and so forth, whatever letters we pick. These are the two most commonly used, but it could be any letter in front. It does not matter. Okay? What it means is that it's telling you it is a function. So if you see f of x equals 4x plus 2, it's telling you, hey, this equation is a function. Okay? It's also just a fancy way of saying y equals. And the letter is the name of the function. Letter is the name of the function. Looking at example 1 and the 4 pieces of it, why do you think the letter is important? It tells you where to plug it in. So that letter, that name, is telling you like, hey, f of negative 2, but here's the f equation. We don't want to plug it in the g equation or the m equation because that's not what I'm looking for. Do you see what I'm saying? That's why the letters are important. So knowing that, what was replaced to put an x here? I mean, to put a, dang it, to put a negative 2 there? X. Okay, so this is telling me x is negative 2. If I know x, what am I looking for?
You look for
Y. Okay, so knowing that, we're going to take this x, this f equation, and when you rewrite it, instead of writing x, you're going to put parentheses. Do you see how I rewrote it, but with parentheses instead of x? We're going to plug in the number instead of x. people outside. Sorry. I made everybody look. There's a teacher. Okay, so I want you to realize you can do this by hand. Okay, what's negative 2 squared? It's 4. What's 3 times 4? 12. What's 12 minus 5?
8.
Eh,
Dang, I was close.
7.
See, told you.
Okay, so we could have done it by hand. I want to show you. Goodness gracious. Okay, if you look here, we can also just type this in our calculator. 3 parentheses negative 2 parentheses squared minus 5 gave us the answer.
So we're gonna need to show her.
So you need to show that you plugged it in correctly. And if you can show me that and give me the right answer, I'm giving you credit.
Okay.
Okay?
I don't like somewhere because it's so simple. Like, you just get them like that.
Maybe.
But then teachers over here can say you need to show.
Did I say you had to show every step?
Yes.
No, I didn't. I said you just have to plug it in.
Oh.
Goodness gracious. Listen. Okay, so this says g of 3. So we're going to use the g of x equation. Remember, rewrite it without the x and put parentheses where the x was. So what am I plugging in there? This one should be easy. What's 4 times 3?
12.
What's 12 plus 1?
13.
So that one was pretty simple without calculators. Now, could you have used a calculator?
Yes.
Yep.
I would use it. Just use it. Make a good use.
That's why I give it to y'all, so you can use it.
It's a good use.
Okay, so this one just tells me f of 2 over g of 2. So f is 3 parentheses squared minus 5. And I'm going to plug in a 2. G is 4 parentheses plus 1, and I'm going to plug in a 2. So what does that top equal? 7. Okay, and what's that bottom equal? I was about to say the same thing. Why every time we hear that do we feel like we need to chug along with it?
Well, you heard me.
I did. I have mom ears. I hear everything.
You can't hear me.
I could. Okay, so this last one is m of 2/3. So we're going to use the m equation. Negative 3 parentheses plus 5 and plug in our 2/3. Again, y'all, you can type this in your calculator. I know a lot of y'all see fractions and y'all freak out. Okay, so negative 3 parentheses 2/3. 2/3 is just division. Plus 5. What's our answer?
I'm gonna guess 8.
I just had the answer on the board, child.
Oh, I didn't see it.
But alright, if you got mom ears, tell me why whenever like you call your kid down, like downstairs or something,
When you call-
and
they
then
say yes.
and they say
Yeah.
what, and then you just don't respond.
And you just keep yelling their name.
Because I know they heard me.
It was messed up, but we say yes. And then y'all don't answer. And then you have to walk there. And
That is because that's what we wanted.
Why not just say come here?
Why not just come here?
That's like mom slang.
Okay, I want y'all to look at example 2, and I want to see if you can find your mistake.
I can make a mistake.
I want to see if you can find the mistake.
I found a mistake. One day I teach my child math. I'm like, find a mistake. He's like, here. I'm like, that's wrong. It's you. And I'm gonna cry. I'm laughing just by oh no, it's gonna be cold again. I already feel it coming. It's too much for this. It's too cold. I'm getting acid from it. Find a mistake. Oh man. Wait, find a mistake. It's not mistake, it's mistake. because you could mistake something for something else. Legit.
Okay, does anybody find it?
That was I found a mistake.
Where?
I think it's in the second question, right?
Where at?
Where I don't think. Wait, yeah, the part where
Is it there?
multiply negative. No, wait.
It's this negative right here.
Oh,
What's a negative squared? Well, isn't that just a negative times a negative?
Yes.
So it should have been positive, but they kept it negative. So right there is our mistake. So should be positive. Now, these two are my favorite because they're super simple and there's no math. You ready?
no.
Yes. You're ready. Ready or not, here it comes. Okay. This is telling me x is negative 2, so I'm going to go on my x-axis and find negative 2 here. What is the height of that graph right there? 4.
Negative 2, 4.
That's it?
That's it. Okay, so at a half, what's the height of this graph at a half?
And a half.
0.
I was about to say.
What about 2?
Well,
Negative 1.
negative 1.
So negative 2 is 4. A half is 0. And then negative 2, it was negative 1. Did y'all see those 3 points?
You should get us like more answers.
Oh, this is going off of X. I was going off of
Yes. Remember, inside the parentheses is giving you x. So remember, when you're given x, you're looking for y, and y is your height. So we just had to find the height at those x values. Okay? And then lastly, this one's like the easiest one ever. So it says find g of 3, which tells me what's 3, x or y? X. Okay, where's x3? 3, 2. Okay, so 2 is my answer. So g of 3 equals 2. I want you to realize that means that this is giving you a point, right? Isn't this just your x equals your y, like g of x equals your y? Okay, that literally is what it is telling you. So if you ever see something written like that with numbers instead of x and y, it's giving you a point off the graph, okay? We'll go into that more later. Okay, you do have a practice page. Your favorite. It's really only 10 problems. It should be simple.
Do we have to use our
Good mistake.
Uh-huh. You should be able to finish in the last 18 minutes of class. Okay? It's plenty of time to finish this if you're not playing on your phone. Keyword, not playing on our phones like some of us did during the lesson.
Oh, that was somewhere. That was me.
They know.
Wait, so the first one,
Is it a function or not? There you go.
Calm down, sir.
Yo, that's why I'm like, okay, 10 problems, you can do it really quick.
Is that a threat? You go to someone and say, don't make me cough on you.
Yes.
That's fun.
Pretty sure you could get in trouble for that right now.
wait, so
Except for number 1, we just put. You just put.
Did you see my face?
I'm confused.
I accidentally hit the thing that made me go down and it scared me.
Do we put relation only for number 1?
Yeah, or not a function or whatever.
Oh, okay.
One thing to tell y'all during this unit is I'm not giving full answer keys to check your work because a lot of this, if I gave you an answer key, I'm giving you the answer because a lot of it doesn't require work. A lot of stuff in this unit does not require work. So I give you partial answer keys. Like on the domain and range practice, I'll give you some with the domain, some with the range, so on and so forth. So you can check a little bit of it. Does that make sense? Okay, and then on others, so it's that concept. Okay, I do want y'all all look at number 5 really fast. Okay, it says find the domain and range.
Of all of them?
So it's gonna, of the 4 dots. Okay, I'm gonna help you with range. Domain is gonna be the same as we did at our beginning of our practice, but remember how I said you cannot repeat numbers? So look at your height. What's the height of all 3 of these dots?
Negative.
Okay, and what's the height of the one other dot?
A 0.
There's your range. You don't write -1, -1, -1, 0. You just write -1, 0.
wait, so that was a negative one?
Because see how all 3 of these dots are at a height of -1?
Yeah.
That's why.
Okay.
And then this dot is at a height of 0. Now domain is your left to right. So start farthest left and pay attention to your side to side.
And so the other one will be like negative
I think it's -2, -1, 0, 4.
Wait, so if range is up and down,
Domain is side to side.
so then
So if I did domain here, how far to the left is that point?
the last one?
-2,
As far as the numbers.
-1, just count. This one's in the middle at 0, and this one's all the way over here at 4.
Oh, that's it?
Does that make sense? Okay. Now you have to answer if it's a function or not.
It's
Don't tell me. Write it down.
I hate when they say explain